Welcome to today's lesson. Today we are on lesson 1-7. Our learning objective is to identify a geometric series and work with sigma notation. Our language objective is to explain what makes a series geometric. So let's take a look at today's do now. Let's take a look at today's do now. What is the pattern in the given sequence? So pause the video and try to find the pattern. Let's look at our thinking for today. What is a series? Recall, a geometric sequence contains a common ratio r and the first term u sub 1. A formula or expression that mathematically describes the pattern of the sequence can be found for the general term u sub n. This is the nth term of the geometric sequence. Geometric series, sum of the terms in a geometric sequence. To find the sum of the n terms of a finite geometric sequence, we use the given formula, where r does not equal 1. So let's look at example number 1. Example 1. Geometric series. Calculate the sum of the first 8 terms in the geometric sequence 20, negative 10, 5. So the first thing that we are going to do is find the common ratio and the first term. Identify those two. So we can clearly see that the first term is 20 and the common ratio is multiplied by negative 1/2. Knowing that, we are asked to find the sum of the first 8 terms. So I am going to use our formula and plug in 8 for n. Now that I plugged that in, I am just going to use my calculator to evaluate this and get my sum of the first 8 terms. Okay, so my final answer is 13.3. I used 3 significant figures instead of writing out the entire decimal value. Let's look at number 2. Number 2. In a geometric sequence, let u sub 2 equal negative 30 and s sub 2 equal negative 15. Find u sub a and r. For this problem, they want us to do 2 things. We need to find the common ratio, and u sub a is really what we know to be as u sub n. So we want a formula that we can use. They gave us the second term and the sum of the first 2 terms. So I am going to just think about this, and I know that to find the nth term, we would use the given formula. We could use a manipulation of this formula to help us find what we need to find using what we have. So I am going to replace this. Instead of using the first term, I'm going to use the second term. And I can manipulate the formula in that way. And the pattern will continue. I could use the third term first and have r raised to the n minus 3. But what we are going to use is this one right here, since we do have the second term. So instead of writing u sub n, I am going to represent this as u sub a. So this is our rule. This is what we are going to use. So let's see how that's going to help us. I am going to plug in what we know. So we do know u sub 2. That's all I know as far as right now. I want to find r. And I have been given the sum of the 2 terms. So what we're going to do is, I know that the sum of the two terms formula would need that first term. So somehow I need to figure out what that first term is. So I'm going to use our updated rule and find the first term. And so far, this is what I have. U sub 1 is represented as negative 30r raised to the negative first power. Let me see if I could clean it up slightly. I'm going to represent that negative exponent to be a positive exponent. So how do we do that? We write it as a fraction, right? 1 over r to the positive first power, which means that u sub 1 can be represented as negative 30 over r. And since I have that now, I could actually replace my u sub 1 in the sum of the two terms. So let me keep going. At this point, what we want to do is use the sum formula for S sub 2. So S sub 2 is obtained by taking the first term, which we know to be negative 30 over r to the second minus 1 over r minus 1. So our goal is to get the value of r, the common ratio. Now, do we know what S sub 2 equals? Yes, S sub 2 equals negative 15, which means I'm going to replace that S sub 2 with that negative 15. And at this point, what we want to do is clean it up as much as possible so we can solve for r. So I'm going to cross multiply and distribute to try to clean this up. Okay, so this is as far as I can go. At this point, I know that I have a fraction, so I want to eliminate that fraction, which means that I'm going to multiply every single term by r. At this point, our goal is to get everything over to one side so we can somehow factor. And let's use our factoring skills to solve for r. So I get r is equal to negative 2 or r is equal to 1. Now let's just think about r being equal to 1. Is that even possible? If that was our common ratio, that means that our sequence would be exactly the same. There is no sequence at that point. So I am going to reject that possible answer, which means that r is equal to negative 2. And our u sub a is equal to our original new rule. So let's try the next one. Alright, so for here, we have calculate the sum using two different ways. And we have some sort of sigma notation. So when I think sigma, I know we have to add. We're starting off with our first term being 1, our k value being 1, and we're going all the way up to 4. So I'm going to do that as my first way. I'm going to just add and plug in k equal 1 all the way up to k equal 4. So I'm going to set myself up. Alright, so all I did is place my k starting at 1 all the way to 4. Now I'm just going to evaluate this. And let's calculate it further. So the sum of the 4 terms would be equal to 40 over 9. The calculator gave me that decimal value and I changed it to a fraction. So what's our second way? For way number 2. What we are going to do is use the sum of the geometric sequence. So first thing I want to do is identify our nth term formula. And when using this formula, we always need the first term and our common ratio. Now let me just quickly look back at the given formula. If you notice, this 3 is actually u sub 1. And this 1/3 would be my common ratio. So I have u sub 1 equal to 3 and our common ratio equal to 1/3. Now that I have that, I am going to use the sum of the n terms. So we are adding 4 terms from 1 all the way to 4. And I'm going to replace my u sub 1 and my r. And at this point, I'm going to input this into my calculator. I get the same value as before, which means that the sum of the 4 terms is equal to 40/9. And that is it. So keep learning, keep growing, and I will see you in our next video.